Hey, good morning, everyone. As we wrap up our finite element and answers section of this class, I would like today to make sure I answer all questions in about answers or finite element methods. We are going to have a quiz tomorrow that's going to cover the earlier homeworks that you've done. Homework 5, 6, 7, and 8, the finite element method, the matrix method, as well as using beam elements. And then next week, we're going to have our second exam. So let's make sure we are all well prepared for this. Let's make sure we're all well prepared for this. So I would really have lots of room today for questions. We're not learning any new material, but it's a good opportunity that we meet together and I take any questions that you have that you figure out while doing the homeworks. And if you have any questions about the quiz or exam, I'll be also happy to take them. Before I open it up for questions, I would like to shed some light on axial or normal stresses using solid elements. So I would like to share my screen here. So what you see here is the simply supported beam that we analyzed last week. So this is made of solids and it's a simply supported beam along the z-axis. So the axis of the beam here is the z-axis. And when we were looking at creating results, you go to results, and now because we are doing solids, your stress results are no longer grayed out, but you can select stress. And one of them is a normal stress. Normal is perpendicular to the face, which can be considered an axial if I pick the proper face. So when we had that discussion last Tuesday, I did create a normal stress, but I want to show you here, if I come back and create another normal stress. Now, when you look at the details of that normal stress, so here when I look at the normal stress, and you see that orientation is chosen as a z-axis. And when I do that, which is the axis of the beam, I can clearly see the tension at the bottom, the red, positive stress, and the compression at the top, negative stress, equal and opposite. And really very nice, very well depicted here. And as you go towards the simple support, you're getting the green here, which you see is around 0. At the neutral axis, the stress is 0. So this is a very nice display of the stresses as we know them. Again, tension and compression. On the other hand, if I do a normal stress and leave this as x-axis, in my case, of course, when you're doing the shafts, you're most likely using x as the x-axis. But if I use x, which is really the one perpendicular to the axis, or even pick y perpendicular to the axis, we don't see much of an effect. So if I solve for this one, you look at this, we're pretty much looking at a 0 here compared to the normal stress in the x-axis, where we were looking at 68 psi. So on your homework, when you're looking at finding the axial stress in the shaft, please make sure you are using normal stress and selecting the direction of the axis of the shaft. Direction of the axis of the shaft.